Hi guys, Audrey here, and this is a JAC capsule on factoring. In this video, we're going to learn a little bit about factoring by grouping. Let's get to it. All right, so what is factoring by grouping? First, we'll talk about when it's useful. It's useful in two main situations. The first is when you have a polynomial that has an even number of terms. Polynomial with an even number of terms. And mostly we see it when we're factoring cubic polynomials containing 4 terms. Now, it can also be useful when we are factoring non-monic quadratic polynomials. So that would be a polynomial that has the highest power of 2 and where there is some non-1 value in front of the x squared. So ax squared plus bx plus c. Now in this video, we're going to kind of come up with some steps for factoring by grouping, and we're going to use it to factor a cubic polynomial with 4 terms. In future videos, we'll understand how it can be useful for non-monic quadratic polynomials. So we want to actually factor the polynomial 2x cubed plus 4x squared plus 4x plus 8. Now, if you know how to factor this polynomial, pause the video, do it, then come back, double check your answer. If not, we're going to go through the steps of factoring by grouping and see how they apply to this specific polynomial. So the very first thing that we want to do is separate our polynomial so that it has groups each containing 2 terms. So we are going to separate into groups of 2 terms. So in this case, that would look like 2x cubed plus 4x squared plus 4x plus 8. And notice that by separating, I've just stuck parentheses around the groups of the 2 terms. The next thing that we're going to do is factor out the greatest common factor from each of those terms. The GCF from each term. Well, in my first term, I see 2x cubed plus 4x squared. Actually, we should say from each group right here, from each group. So in my first group, 2x cubed plus 4x squared, the lowest power of my x is 2. I can think of 4 as 2 times 2. So my GCF here is 2x squared. And my second one, I can think of that 8 as 4 times 2. And my GCF is actually just equal to 4. And we're going to factor that GCF out of each group. So I'm factoring out the 2x squared. What's left over? Well, I took the 2 away from 2x cubed. I took 2 x's away, so I have 1x left over. I took the 2 away from 4, so I have a 2 left over, and I took the x squared away. So that's 2x squared times x plus 2. Then I'm going to factor out the 4. What's left over? X plus 2. Now, my last step is factor out the new greatest common factor from the whole thing. And what that means is this factor that showed up, that x plus 2 is now in both of those terms. So I'm going to factor it out to the front to get x plus 2 times what's left over in the first term, 2x squared, what's left over in the second term, 4. And this is my final answer. Now we're going to have a fourth step, which is don't forget to check if any further factoring can be done. Don't forget to check if further factoring can be done. And the answer in this case is actually yes. Why? Because I didn't factor out the GCF when I started. I could have, and that would have been great, but I didn't. So what you'll notice here now is that this 2 and this 4 do have a factor in common. This right here has a GCF of 2. So when I factor that out, I'll have x plus 2 times x squared plus 2. So this is 2 times x plus 2 times x squared plus 2. And this is now fully factored. Note that I could have factored out the GCF before I started because there is a common factor of 2. Also, in this case, I ended up with a sum of squares, which cannot be further factored. But if that had been a difference of squares, then I would have been able to apply my difference of squares formula. All right, that's factoring by grouping. Bye, guys.